Good morning again. Good morning. Okay, today we're continuing with introductory topics. We will do units of measurement and converting from one set of units or one quantity to another. Conversions and units. Units of measurement. There are many things which we measure, but we will only consider, for this point here, units for mass, length, and time. You say, why don't you consider units of volume? We already have them. Units of length cubed will be volume. I don't know why I wrote it that way. So we need to look at units of mass and length. Time unit we'll write off right now as being the second. 3,600 seconds, 1 minute. Now in the old days, empirical units or avoirdupois units went, very complicated. For example, British units, 12 inches, 1 foot. The length of Henry VIII's foot, arbitrary. 3 feet, 1 yard, 5.5 yards, 1 perch. 5.5 yards, 1 perch. The stride of a horse, maybe. 220 yards, 1 furlong. 8 furlongs, 1 mile. 8 furlongs is 1,760 yards. That's a statute mile. And guess what? 7 miles in a league. I always wondered, there's a book by Jules Verne that says 20,000 leagues under the sea. Well, wait a minute. We take the Earth. Its radius is only 4,000 kilometers. How can you get 20,000 leagues under the sea in a submarine? Okay, after a while when I was a kid, I thought about it. I think they mean this. I think they mean sailing around the Earth many, many times underwater. 20,000 leagues under the sea. So, what's a league? A league is 7 miles. Since we're talking about the sea, there's another thing, the fathom. The fathom is 6 feet. These are very difficult units to manipulate because of the number system that we work with. We work in the base 10. So, it was proposed to introduce into the sciences the units based on the base 10. In other words, powers of 10. Positive or negative powers of 10. 10 squared, 10 cubed, 10 to the 6th, whatever. 10 to the minus 1, 10 to the minus 2, 10 to the minus 3. Just like what we saw in our first lecture, scientific notation. So, our unit system is going to be the SI system. And we will not veer from that. For example, when we're doing chemistry, we will not launch into the universal gas constant expressed in liters. We're going to stick with these things for simplicity. Units of mass. Let's start off with units of length because they come first. Now, in terms of dimensions, sometimes people write these things. Dimensions. But the length unit will be the meter. The mass unit will be the kilogram. Not the gram. And the time unit will be the second. Okay. So where do we begin? We begin with our unit of length. Now, an absolute unit is the Planck length, and I have a little derivation of the Planck length, but for an arbitrary unit, what can humans do? Well, we already had the second. The second was in existence, right? 3,600 seconds in an hour, 24 hours in a day, 365.25 approximately days in a year. So, somebody has to sit down and come up with a reasonable unit of length. the length of Henry VIII's foot. That's too personal. His foot is that length, and they call it 12 inches. Sir Christopher Wren. He was a great man. He designed St. Paul's Cathedral in London, amongst many great other buildings in London. Basically, he restructured London after the Great Fire. He's also responsible for one of the conservation laws. I'm not sure which one. Could be momentum. Momentum is forecast in Newton's third law. For every action, there's an equal and opposite reaction. But I think Wren had something to do with its conservation law. Anyway, he also proposed the meter to be the length of a pendulum to give a certain period. Well, if we have a pendulum, put the mass on the end of it. The period is the time for it to go over here and back again. So it's a circle, right? It's an orbit squashed. It's not over here. So Christopher Wren says, make a pendulum whose period is going to be 2 seconds. That means from here to here is 1 second. From here to here and back again is 2 seconds. Now from your 8th grade, I don't know if you did it or not in the 8th grade, the period of a pendulum is given by t, period, equals 2 pi, the length of the pendulum, over g. And g is a number. We will learn about that later. It's a number. It's an acceleration due to gravity. One way or another, let's solve for this. We're solving for L. I squared this, divide that, sorry, and now I get L. As being 1 meter. Now if I put in all these numbers, for t squared, it's going to be 4 and I get approximately 1 meter. Okay. They cancel. Pi squared is possibly 9.8. So our unit of length is that length of pendulum string to make 1 meter. Now we go on to the unit of mass. Common commodity on the earth is water. Water is all over the place, but it's not necessarily pure. It's not distilled. So, but at a standard temperature and pressure, we can take pure distilled water. Now we'll divide our meter into 100 equal parts. We'll call each one a centimeter. And we take a little box of volume 1 cubic centimetre and fill with water. We'll fill it with pure distilled water. Find the mass of water in there. Find that mass and call it 1 gram. Now, as on the side, we'll take this little volume here and create a little volume unit with it. We'll call that little thing a milliliter. So therefore, 1,000 cubic centimeters. As a volume of 1,000 milliliters, and that volume is 1 litre. So we actually, on the side, gone over to our chemist's unit of volume. Physicists don't use litres. Physicists use volume. Volume units like that, cubic meters, that's what we use. And in this course, if we need volume, we'll talk about cubic meters. So, let's look at the gram. Now the mass of 1,000 grams is a kilogram. That's also the mass of 1,000 milliliters of water. It's also the mass of 1,000 cubic centimeters of water. And of course, 1,000 of those things, 1,000 grams, is a kilogram. So a kilogram is the mass of a litre of water. So if you want to go out and find out what a kilogram is, get a litre of water. So now we have units of mass, set, length, and time. Volume units come along. Now we're going to take these base units the kilogram, the metre, and the second, and find multiples and fractions. Let's just do the gram. Actually, let's do the metre. Ten decimeters is 1 metre. So 1/10 of a metre is 1 decimeter. We can write this like this. 1/10 of a metre. 1/100th of a metre. 100 centimeters is 1 metre. So therefore then, one centimetre is 100th of a metre. We can also write that as 10 to the power of minus 2 metres. Millimeters is 1 metre. 1,000 of a metre is a metre. 1,000 metres 1 millimetre, or 10 to the power of minus 3 metres. Now we could go further, but I'm starting to go up now. That's enough. Well, let's just do micrometers. A micrometer is a millionth of a meter. So, the abbreviations I've used throughout here was mu for the micro, m for the milli, c for the centi, and d for the deci. So far, so good. Guess what I could do? I don't have to talk about meters. For the same setup, I could use grams. Just replace everything with a G. Everything goes to G when we do grams. We could also use liters. And all the same prefixes apply. Now, we're going to go big ones. We're not going to do 10 meters as a decameter. We're only going to use one. "1,000 meters is a kilometer. 1,000 grams is a kilogram. And kilo stands for 1,000. So that's the way our units work. Now let's convert. How do we convert from one unit to another? Well, we can't convert from grams to meters, but we could convert from grams to pounds. To convert, you need a conversion factor, but we'll stick within the SI system first. It's convenient to use a unit factor and not do it in your head when you're converting. In mathematics and physics, let your hands do the calculating, not your head. The unit factor is 1. Multiply anything by 1, you get the same thing. So unit factor doesn't change the value of anything. Examples. Week is a unit factor. Convert days to weeks. Now we know 28 days is 4 weeks, but so what? Let's do it. To convert, we always use our unit factor. When we use a unit factor, the thing we want to get rid of is the days. That goes downstairs because we want to cancel. Now we construct the unit factor. The thing we want to end up with, it goes upstairs with the unit factor. In this case, it's weeks. So 1 week is 7 days. That's the unit factor. The days are gone. So we get 28 over 7 weeks, or 4 weeks. That's a unit factor. That's an example of a unit factor. Another one could be converting hours to minutes. We could do it that way as well. Let's look at conversions in the SI system. Conversions. Now, SI conversions are very simple. Here are some kilometers and centimeters, some unit versions in meters. I could equally make these grams. The M can be replaced by gram. Or it could become liters. So we'll do an example. Convert 6,500 grams to kilograms. Well, you know in your head it's going to be 6.5 kilograms, but we'll just go through the process because more complicated problems can come along. We select the suitable unit factor. We need one to cancel out the G. We need to end up with the kilograms. Now we ask ourselves, how many kilograms or grams we got? What is it, 10 kilograms a kilo? No, it's 1,000 grams is 1 kilogram. And we get 6.5 kilograms. We will do one more, but using small numbers this time. Convert 72 million milligrams to grams. Okay. Actually, I'll say to kilograms. Okay, so we need a unit factor to get rid of the milligrams. This is a two-step problem. We'll do it in 2 steps because we'll make milligrams grams. Then we get rid of the grams and make them kilograms. So we have 2 unit factors, one to get rid of the milligrams, one to get rid of the grams and make it kilograms. We have to see what the unit factors are going to be. 1,000 milligrams is 1 gram. (1,000 grams) is 1 kilogram. The grams go, the milligrams go, and the kilograms stay. Downstairs I have 1,000 times 1,000. Now we cancel out. Kilograms are the units that are left. 1,000 cancels out, and 1,000 cancels out. And we get 72 kilograms. That's enough examples for now. There are more to come. Actually, do one more. We'll do one more general example, and then we'll leave it at that. Because this one crops up a lot. This time we're going from meters, miles to meters, or meters to miles. But we need a conversion factor. You need to have that as a given. It's actually 0.03. Or something like that, I'm not sure. So we go. We need a unit factor to get rid of the miles and end up with meters, and we have our unit factor as being 1609 meters is 1 mile. So we get 4 times 1609 meters, which is 6436 meters, and that is 4 miles. That's enough for this session.